Right. So we can mention the definition. Nithara, did you mention the definition? No. Yeah, Minuki, tell us.
Energy change when 1 mole of water is formed as a result of reacting an acid with a base under 290 Kelvin temperature and 1 atm pressure.
Right. So we have to understand the way of measure enthalpy change of neutralization. In order to measure enthalpy change of neutralization, then we can use this type of apparatus we call cup calorimeter. How do we make a cup calorimeter? So we can use a polystyrene cup as well as a lid. Polystyrene thermally, mm, we can say insulated and not able to release heat energy. So then uh, add mix acid and alkali. So then that could be caused to produce salt and water. And then it is possible to measure the temperature change. And if we know the mass of this reaction mixture, we can use Q equal MC delta T equation. Q equal MC delta T. Okay, Nitara, draw this diagram then. Right. So we can do the calculation part then, right? Uh, over here. So we can use Q equal MC delta T. Meaning, what is the mass of this reaction mixture? Mass of reaction mixture. Yes, Netara? We get mass of reaction. M is mass, no? We have to find the mass.
We have to calculate it.
Yeah, we have to calculate. How do we calculate? So we can say, we can assume both those two solutions density as 1 gram per 1 gram per cubic centimeter. What is the meaning of this? 1 gram per cubic centimeter, which means 1 cubic centimeter mass is 1 gram. This is density. We have to assume, otherwise we can't find. So then if it is 1 cubic centimeter, 1 gram, 25 cubic centimeter. What is the mass then?
25.
25 gram. So this we can say 25 gram. This also we can say 25 gram. What is the total mass then?
50 gram.
50 gram. Good idea, no? So that is the way we have to get. We have to assume density as 1 gram per cubic centimeter. Then 25 cubic centimeter mass will be obviously 25 gram. 25 and 25 because we have to mix both those two, right? So this contain both acid and alkali. Acid is hydrochloric acid, alkali is sodium hydroxide. And specific heat capacity. We have to assume this contain water mainly water. Water specific heat capacity 4.18 joule per gram per centigrade degrees into temperature change. Initial temperature, we can take the mid value 18.6 and 18.8. We can say 18.7 average value, right? Between these two. Increase to 25.4. So that is the temperature change, delta T. What is the temperature change then? Use your calculator.
Six point six.
Is that correct, Natara? 6.7, yes, 6.7, no? We have to get the 18.7, no? 25.4 minus 18.7.
Why is that, sir?
Because we have to get the average initial temperature. 18.6 and 18.8 add and divide by 2. Then we can get the average 18.7. 6.7 centigrade degrees. So we can get the QL.
Okay, if I copy this here,
Okay, okay.
put it on the book.
Yeah.
So what's the page?
Uh,
Okay, sir.
all right. Nitara, what is the value you got over here? Joule? 1000, 1400.3 joule. And we can convert this to kilojoule divide by 1000, no? So then we can say 1.40 kilojoule. 1.40 kilojoule. And if we divide Q, heat energy from number of mole, then we can get the enthalpy change. How do we find number of mole? Number of mole we can get N equal concentration times volume. Concentration times volume, and there are two substances, hydrochloric acid and sodium hydroxide. Which one limited amount? Hydrochloric acid, no? Because here 1 mole per cubic decimeter 25. Here sodium hydroxide 1.2. So which means we can say sodium hydroxide in excess. Limited amount there, hydrochloric acid. So which means we can get the number of mole. Concentration, we can say 1.00 mole per cubic decimeter into volume is 25 over 1000. We can get number of mole. So we can say 2.5 into 10 to the power minus 2. Am I correct, Nitara? Yes. So then if we divide heat energy change from number of mole, we can get the enthalpy change. Enthalpy change answer, we can get kilojoule per mole. What is the value? I don't think. You had to put bracket in the calculation. $56, no? Then the sign, plus or minus, exothermic or endothermic. Okay.
Endothermic.
Nitara, what is your opinion? Initial temperature was this much, 18.7.
Okay. No. Exothermic is
Exothermic, because temperature
increase.
increases. If it is exothermic, the sign should be over here, minus sign, right? Are there any doubt? Then next we have to consider standard enthalpy change of formation and Hess's law. Standard enthalpy change of formation and Hess's law. Right. Standard enthalpy change of formation of Hess's law I'll discuss in your next session. So this lesson very important to draw a cycle also, no? So that is the one we'll keep most of questions we can